All right, then. So let's get started. Thank you, everyone, for joining us again for our data engineering interviewing series with Anju Mercian, focusing on Python, SQL, data modeling. Really happy to see everyone here. So about our speaker, Anju, she graduated from Syracuse University, New York, with a master's degree in computer engineering. Her previous work experience includes Intel for 5 years as an infrastructure engineer, VMware as a project manager, Intuitive Surgical as a business system analyst, and I'm saying this right, Omdena as a platform engineer. And she is currently a data engineering consultant at Meta Facebook. And Anju, can I hand the microphone over to you?
Yes, thank you so much. Yeah, let me share my screen. Thank you so much, Eliza, for the introduction. And thank you all for joining the session. So this is actually a third session in our series. We had first two detailing, the first one was SQL. The second was like we had a theory of data modeling, and today we're actually going to run into run into an exercise with data modeling. So this will be like a interview question that usually you would be given it. So this is, if you have attended a software engineering interview, this is like system design of software engineering interviews. Just like, it's a database design, but if you have to say so. So this would be like an interview question. Sometimes they can ask many different, this is just like one type that, just to help you understand how to think through a data modeling question. So I actually, this session may be shorter compared to the last two sessions because I'm going to only concentrate on the data modeling exercise. And if you have any questions, please keep bringing it in the chat and the Q&A, like wherever you see appropriate or wherever you'd like to send your questions in, because this I'm expecting it to more be like a interactive session, because I'll go through the concepts, and then when I am discussing the tables and the schema and everything, it'll be nice if you have questions, because when I am just sharing this information, this was only completely like what I am thinking, when you may be thinking something different and be like, oh, maybe why couldn't we use this, why couldn't we use this column, why couldn't we have, so we can actually discuss through that. It'll be very helpful even for me as a learning process and for you as a learning process. So if you have any questions, anything to say, please feel free to put in the chat on the Q&A, and we can have a discussion through that. That'll be wonderful. So I'll have both of it open, so that if you have any questions, you can go ahead and keep asking me. So I'll start off the data modeling with some recap, and then go into like problem solving side by side. Okay. This will be a faster class, so because I'm expecting more questions and more interactions. So I'm actually reading this book called Fundamentals of Data Engineering. It's a nice book. So in that, they're actually talking about a data engineering life cycle. And this is actually the diagram that the authors have come up with. So this is the complete data engineering life cycle, right? So data is generated somewhere. So everything that we do, like working on our phones, the metadata, anything we purchase, our internet usage, everything is it's stored somewhere, right? That's how the data is being generated. So all of the data is in logs, and it is somewhere. So from that generated data, we have this, what we have to create as a data engineer is this, the ingestion, transformation, and the serving. That is what a data engineer has to do. That's the main job of a data engineer. And get the data provided to analytics or machine learning or reverse, somewhere else, like business intelligence. So this actually, I really liked this this life cycle diagram. So I actually wanted to share with all of you. This is kind of gives us a gist of the data engineering life, actually. So most of the time, the ingestion is usually that's the SQL and everything that we are doing. In the transformation stage is where this data modeling actually comes into place. Based on who the customer is, we have to model the data and make sure that our data is in a beautiful format for them to be easily accessible, and they can ask questions, or you can also sometimes some smaller companies, for some smaller companies, data engineers are also the same as data analytics. So So when that happens, you may have to be the analytics person and create the dashboard. And this, having this data and formatted in data modeling, that's where the data modeling stage comes in, and the transformation stage. There are these undercurrents also, which are actually something you have to think about too, because you have to work with, sometimes there may be different teams, or sometimes you may be the one. Oh, could you please, Sarah asked me, Leila asked me, could you please share the details of the, yeah, you know what I'll do? If you're on Slack, I'll send you the whole information. It's called Fundamentals of Data Engineering. I forgot the author's name, sorry. I will share that information on Slack, be easier, so that everybody has it. And also one more thing is I'm actually writing articles in conjunction to the series. So, I'll share the article details too, so you can, and I will mention the book name there too, so that you'll have something to read, because you don't want to go through the whole video again, maybe sometimes. So you have something to read and you'll have the points there. So that will come out somewhere next week or something. So that's actually a good book. Okay, so that is the data engineering lifecycle. So what is data modeling? So in that book, they clearly mentioned that previously, for some time, when there was database architecture like DBAs, and the RDMS phase was that, I don't know if anybody remembers, but it's a long time back when there was DBAs and RDMS related databases. That time they actually thought through and architected data models with data models. But during the 2010s, when machine learning and data science kind of became a boom, nobody was doing this data modeling, and many data architectures failed. That's what they have mentioned in the book. There are many data architectures have failed. And that's why nowadays companies are more focused on doing data modeling. And that's how this data engineer positions came about, so that they can have somebody that completely concentrates on the designing and implementation of data. So that's when data modeling becomes very important. So basically, data modeling is nothing but, in short, something that we design data based on the business process or business logic. So a customer comes to you with a business problem. You should be able to understand the business problem, but also be the data technical person, to translate the business logic into data, and create an architecture which is sustainable, which is scalable, and portable. All of our system design details must be there in that design, so that we can finally give them something that can help solve their problem. So that's basically this data modeling. So think through the problem, talk through the problem with the business, or with whoever comes to you, with the customers, design your data architecture, and provide the data, translate the data architecture to them in data format. So that's basically what data modeling is all about. And this has started happening in companies, and this has to continue happening. And so that's why it becomes a very important part of the interview process to understand. So why is data modeling important? Data organization is crucial because organized data can help reduce complex queries. We can have performance optimization, which is very, very important as a data engineer, for you to know how to have optimized data, optimized queries, to help with complex reads, and help to write faster, enabling efficient retrieval, reduces redundancies, reduces storage requirements. Organized data determines later data use. So scalability helps add flexibility when more data is to be added, because we can't keep changing our data tables, right? So when more data needs to be added, or more columns need to add, the data should be placed in such a way that it is scalable for the future and flexible. So that's where data modeling comes into place, right? Okay, so the question that I was talking to you last week, before we close the session, the question was, you have been asked by a daycare management team to help create a database to help them analyze, manage, and grow their business. Okay, so this is what they have given you. Just plain, they've hired you, they've asked you a question, hey, help me manage my business, and also I want to grow my business. Business is very slow right now. Help me with grow my business, right? So here, what you have to note is you have this word analyze. right? So from this one word itself, you can understand whether it is something, whether the database that you have to create will either be a transactional system or an analytical system, right? So since it's analyzed, so this will be more of a data warehouse instead of a data, what is it? Data transactional system. Okay. Okay, so there's a question Samina has asked, as RDMS were used earlier, can you please mention a few of the current databases that are mostly used in different projects? Databases that are used in different projects, like actually even right now RDMS is used primarily the SQL what do you say, the SQL grip we have not lost the SQL grip yet. SQL is currently, and I think for much longer time SQL will be the only thing that's holding the data, even though we have like Apache Cassandra, which is a NoSQL, we have Presto, we have Hive. All this is supporting big data and big databases. Big data. Give me 1 second, please. Sorry. Sorry about that. Yeah, so there are so many such databases available, and even SQL data. But again, everything has the flavor of SQL. So if you say relational database, currently that's used, PostgreSQL is used primarily as a RDMS. PostgreSQL is MySQL, or MySQL is used for individual projects. But if you're just using SQL for big company, Postgres is used, but they also will have their own, like Netflix and all those companies, Airbnb, they have their own kind of RDMS, which they have created in-house. They call it their own name. So.
Great, Anju. There's one more question, Q&A, and then do you want to get started on helping people set up their own database?
No, we won't be setting up a database. We're just going to work on the thing, on the. So basically, this is more of understanding to write the concept. So this data design, even in interviews, it'll be more of you talking through the process on a whiteboard. This is basically will be a whiteboarding process. You'll be talking through it.
Okay.
So
there is one question in Q&A if you want to answer that one, and then we'll wrap up that. Can you see it, or do you want me to read it for you?
Yeah, I can see it.
Okay.
Sorry. I was looking at the chat only. I didn't. Is data modeling a specified field of backend engineering focused on efficient and optimized data retrieval? Is a specialized. So data modeling is not a specialized field, but it's part of being a data engineer. Like it's part of knowing it as part of being a data engineer. This is something like system design for a software engineer, right? For a software engineer, knowing how to design a system. If they say a hotel reservation system can also be a data question. How will you create tables and everything? So this will be same as that. So as a data engineer, it will be it's pivotal to know how to model as a as data engineer. So if you're a backend engineer for data, this is something you will have to know, modeling data. Okay, so so basically in this, if you see the question itself, it's not going to be like a transaction system where the daycare worker will be entering day-to-day events or something like that. Here they're asking to help them grow their business. So it will be more of like a data warehouse that you'll have to create. Now you can ask me, hey, why can't I just use data lake? Now, yes, you can use data lake, but that will not help you in creating a good data warehouse to help them grow the business. Because if you create a data lake, from the data lake, who takes up the information should be another data engineer or somebody that knows programming or data, how to look at data. Now, if you see a data care management system, it will be more of the business side. They'll know the business very well, but they'll not know the technical parts very well. So you as a data engineer must be able to give them anything that's chewable and digestible kind of stuff. So data lakes is out. It's not transaction system, data transaction system is out. So this will be an OLAP, which is an analytical processing system. Okay, so that's what we are going to design. So data modeling has this 3 stages that we have to go through in order for us to get a good end design. It is an iterative process, but this is the process that we have to go through. So I'll just suggest one thing, which is my personal thing that I think I'm saying. Whenever you're talking to a data engineering interviews, always try to use these phrases like, okay, so let's start with the conceptual modeling. Okay, so this is what I'm going to think. This is what I'm thinking about for the conceptual modeling. Bring in these words so that they know that you know what you're talking about, right? Because conceptual modeling is like very data engineer stuff. So you can say, oh, okay, let's start with conceptual modeling. And then you can start with asking them the question. So these are the 3 stages we follow. First is the conceptual stage, is modeling, then is the logical modeling, and then is the physical modeling. Physical modeling, as the name goes, is actually you are writing the code. You're physically writing the code. That's when you decide which database management system you'll use and all of that. But conceptual modeling is completely pen and paper. Okay, you're going to sit down with the Daycare management team or the Daycare person, somebody who contacted you, and talk them through what the questions they want answered. What are you thinking? How exactly would you like the data? So what do you think about how would you like to grow your business? Because you may not know, because you're the data person, you're not a business person. So you need to start thinking through how you'll design. First, you have to understand the business. So your work as a data engineer would be to understand the business. So you're going to sit through the person and do the concepts. Ask them, hey, what exactly do you mean by grow the business? What's happening with the business? How does the daycare business grow? So what are the questions you want answered? What would help you? What kind of data will help you? That will be the first time you sit and kind of understand the business process, the business logic, and everything. In logical modeling, it's all you. As a data engineer, you will be creating the tables, you will be creating the columns, you'll be creating the primary key, foreign key, the null values, the not null values, all the constraints, all of the intricate details of the database. That's what you'd be doing. And here also you're again on pen and paper. Again, you're documenting, you're writing your tables, you're doing the schemas. All of that, again, it's on pen and paper. Then physical modeling is usually not asked in interviews. You can just say, okay, now we can do physical modeling. Sometimes they may ask you, hey, what kind of database you're thinking? What kind of RDMS are you thinking about? Then you can say, okay, I have previously worked on so-and-so, like a PostgreSQL. I have previously worked on MySQL. I'm very comfortable with MySQL. So I think I'll go with it. But sometimes if you know the optimizations of that particular Postgres, it's not necessary that you know, because it's very difficult to know all the optimization of particular RDMS, right? But if you actually have worked on it thoroughly and you know it, then you can also insert that, saying that, okay, Postgres has more better date time library functions. So I'm very comfortable with that. So I prefer that. Or you can also, then they may ask you like, hey, why not use a NoSQL database? Why not use like something like an Apache Cassandra? Yes, it's possible. Apache Cassandra is possible. We can do the same thing. In the logical modeling itself, when you think through it, you can also have same as that in a NoSQL, if that's something they want to use. Because if their database is changing all the time, but then you have to give them reasons why. Okay, because if this is like a database management system, right? This is like a daycare management system. So this will not need NoSQL or like an Apache Cassandra, because we won't have just dump of data. This will have a regular data, because not every day people are going to be sending their kids to daycare, right? Like a new daycare every day. Sometimes they'll be there for 3-4 years until the kid gets to a particular school age and stuff like that. So this particular, I would have said like this particular system does not need a NoSQL because this is not like mobile data or something that you have to keep collecting and have much information. This once, most of the time it's settled yearly, it'll be there yearly. Maybe the teachers may be changing. No, even then they don't change too much. So I will stick with a RDMS, a SQL database, because we can have a better flow. It's not streaming data, so we can have a better flow and have a better design. And unnecessarily, I don't want to bring in a NoSQL. So you can actually say that too. Say you can be, and they can, refute to. And this is a good discussion usually you can have with, but you don't have to take it like too hardcore. But this will be a nice discussion to ensure that they understand that the design very well, the modeling very well, the data engineering you have kind of like touched upon. So that's kind of extra knowledge you can give. So this is how we are going to do the data modeling. If anybody has any questions, please go ahead. You can ask me. Okay, now let's start with conceptual modeling. Here, I just given the definitions, what it is. So we are going to basically write pen and paper. You're going to talk to them, understand the business, understand the business process, what they're trying to get out of the system. Okay, that's what you're going to do in the conceptual modeling. Okay, so the conceptual data modeling has three main things that we need. The entities, the tangible, the intangible that the business wants to capture. Okay, these are generally the tables of a database and can be identified in a model by a rectangular square. Now I'll show you the ER diagram. Okay, and then you get entities, basically the column names, what they want to capture. Then you get attributes. Attributes are basically the characteristics of the entities. It can be understood as columns of a table. Actually, the entities are table names. Attributes are the column names. So the attributes for entity studio worker, for an entity called studio worker, it can be identification number and name. Okay, that's what attributes is. And then the relationship between the different entities. What kind of relationship they like to have. Sometimes they'll not and completely understand what one to many or many to many will be. So you should always be careful when even though you're explaining to another data engineer, another software person who would basically try to understand all this, we shouldn't assume in interviews. We should talk to them like they are the business person who have no idea about the data, relationships, entities are, attributes are. Right. So basically, the three things that we have to do here would be to understand what are the table names that you will create, what are the columns in the tables that we're trying to create, and then the relationship between the columns that we're looking at. So how do we do that? Right. So how do we do that is first we understand the business process. I don't want to keep reading the whole thing. That's why I'm going to, okay. Before that, what is a business process, right? So a business process is a collection of business tasks and activities that when performed by people or systems in a structured course produces an outcome that contributes to business goals. Okay, so basically it's just the task that person will perform. So to get to the outcome of the business goals. So for example, like how many tickets were sold were sold at an event. It'll be customer purchase tickets, right? The business process will be the customer purchases tickets. So that will be the business process. So how many customers purchase the tickets? We should have something like a returning tickets process. The different vendors and metrics for the event, like canceling tickets and vendor list tickets. So all this will be a business process. You understood? Hopefully you understand. So business process, basically what it would take to answer that question, the business outcome, the business question, the logical question that they're asking. That's what a business process is all about. Okay. So now in this scenario, in this daycare management system, what the daycare person is telling us is, in order to grow my business, what I want is, I want to know what is the teacher-student ratio right now. What is like the curriculum of our daycare compared to the curriculum of another daycare? So this is a question they're asking. So because we can't like go and just get the curriculum details of another daycare, right? So we have to like talk through it. We have to first analyze what's going on our daycare in order to get the details. So what is the curriculum compared to the other daycare? The different age ranges in the daycare that'll, do we have to accommodate more ages to grow the business, or let's say, or stagnate at particular age, then what are the other students grouped by age? What is the study and play schedule like? So these are kind of the questions that that they're talking about, okay? That the daycare management team's question. These are some things I would like to understand about my daycare in order to help me grow my business. That's what they're saying. So we have a questions now. So we kind of understand. This is just a high level. They may have more. Maybe you right now. If you are thinking of something, you can also ask me, right? Then we can talk through those questions too. If these are something that I thought about, when I was thinking about a daycare management system, you may have a completely different idea, and you may have more inputs into this. So if you do have anything, please do let me know. Hey, why don't we have this too? So. Okay, so Samina has asked a question. Anju, could you please later share the steps for setting up databases tools to install for our practice if possible? Yes, how to set up a database system? Yes, I can share that. Yes, I can share that. Also, if you don't want to set it up on your system, you can also use Google Cloud. The Google Colab. Google Colab has a can, if you don't want to set them, but I can share, if you like, I can share all the three. Setting it up on your system, then setting it up on Google Colab too. I usually use Google Colab so that my system is not bogged down by too many databases. I already have a lot, but I'll share both of it. Taya has asked a question. How do the rates at this daycare compare? That's a good question. How do the rates compare with the other day? Yes. That's a very good question. So I'm going to give Taya credit here. Thank you. So I wouldn't have this this table in my design. So we'll see how to add it, right? We'll talk about that. So anybody have anything else? How do the rates? Any other question? It's okay. You can keep talking about it. So. Okay, so what would be the business process behind it, right? So the business process for teacher-student ratio will be like a teacher-student ratio based on age of the kids. Okay, another one will be like age-based schedule curriculum for the kids. So we have to figure out the business process will be or have an age-based schedule for the kids. So younger kids will have like painting and drawing and stuff like that. And older kids will have more to study because they have to go to school. Then materials available to the kids. Those are kind of the business process. And with this right now we have rates. So rates. So the rates will be based on age, right? Usually rate will be based on how old the child is. So the child is younger and they have to keep changing diapers. That'll be like a different rate. And the lifestyle is older and potty trained, it'll be much lesser. They just have to teach. So the rates, the business process will be rates based on age. And even when you compare, you'll compare it based on age. So every daycare usually will have. Now, all this is not something you may know as a business. Like they may ask you any question, right? They can ask you streaming questions like Spotify streaming. They can ask you Netflix streaming questions. So you kind of have an idea as a consumer, like you consume Netflix and Spotify and everything. You may have an idea as a consumer, but so you can bring in some ideas too. But this business process and the business process question is something you have to discuss with the business person, with the interviewer in this case, and get those details from them. Because sometimes, and this process should not take too long either, right? Because you only have 1 hour, and sometimes the interviewers will not say, hey, let's stop this here. They may not say that. You have to stop them because you have to make sure that if within an hour you have a data modeling question, within an hour you finish logically designing it. Where is the daycare located is also a good question. Thank you, Mia. I think Mia. Thank you. So you should make sure that when you're going through these questions, you're not taking too long. So I would say around 10 minutes keep around 10 minutes to understand the business and the business questions. After 10 minutes, just ask the interviewer, hey, can I go ahead and start logical modeling? Because if you start discussing this, it'll take long time. See, now we have Mia as a question, somebody else will have more questions, right? This is great. This is great to discuss. I usually like this discussion phase. So, but you should make sure that you don't lose time. So rates based on age will be a question. The location will actually be a good question. Location of where is it? Oh, if there are late pickup changes associated after a certain time, yes. If there are late pickup changes, yes, that's also a good question. Late pickup changes also, because usually some daycares charge after 15 minutes. So that'll also be, so that business process will be pickup times. Okay, pickup times based on age or based on rate. That'll be another business question. Right? So this will be the business process. Does anybody have any questions based on this? Please go ahead and ask me in Q&A or chat. Yeah, food is provided from home or provided from home. Yes, that's a good question. Yeah, Eliza is saying these are very good questions. And
no, Anju, you picked a topic that really resonated with me.
Yeah,
I'm just like, I've never thought of these things. So this is like a learning experience for me too. But yeah, thank you so much, everyone, posting these questions. They're great.
You can actually create this as your own project too, if you like. If you're very interested in creating a data engineering project, you can actually create this as your own project. Go through the conceptual stage, logical stage, and you may not have the data. You can create some dummy data for your questions, but you can actually create this as a project and write it as a paper or blog post, and or you can use AWS. Streaming and kind of do that too, and make this as your data engineering project if you like. Yeah, so I think somebody called Samsung, I don't know who that is, but they have said maybe you can create it as a GitHub project, yes, and make it as a collaborating project, yes. If you like me to do it, I can start it too, no problem. This can be a good collaborative project, and and then you can in the physical model we can extend it to creating it as from have it as an AWS S3. The data can be there, and all that. Ani also said like extracurriculums like yoga, music, dancing. These are very good questions. These are very good thinking. This is actually fantastic. So actually we can have all of this and create our own data engineering project, which will be very helpful for all of us. Samsung is myself. My name is Dipanjali. Okay, nice one. Okay. Dipanjali, hi. It just says Samsung SM. So sorry about that. Okay, so Mia has said that business process seems like a collection of data about the daycare. What is the difference? So basically, what is the difference? Like I usually come like how do you think through it, right? That is what happens with business process. So like, okay, so for example, if you go to your company, you're buying something from Amazon, for example, right? So when you're buying something from Amazon, they'll have return product, right? If you're not satisfied within 30 days, you can return. That return item is actually a business process. It just doesn't happen like that. They need to have a return processing pipeline. If you think about it, right? That's the same thing. It may look like a collection of tables, but it's actually a pipeline. We can't create so that pipeline has to be created in the business side. So if you're trying to take teacher-student ratio, teacher-student ratio based on age is actually like a pipeline behind the scenes that they have to think about. They say, okay, we need to have students and teachers. Now, let's have a group of students in a particular, like 2-year-old, 2 to 3-year-olds, and put them under one teacher so they all have the same kind of learning. So that is actually a process, if you think about it, right? It's like how you return a product on Amazon. This is also like a process. As a business, they have to work on it as a process. So that so they have to like make sure when the kid comes in, they have to make sure that they have the age of the kid, and they have to have a teacher trained for that particular for the age group. based on their syllabus, the daycare-based syllabus, so that they can put the child into that that group of age, so that the child can get as much as possible from that particular teacher, and also they have to make sure the teacher is trained for that age group. The teacher knows how to deal with those people. So everything that comes behind the scenes, that is the process. So when I write it, even for me, when I first started learning all of this, I was like, what is business process? It looks the same. It's like, I don't understand. But if you think about it, I may have not written it properly, but when you think about it, it's actually the process of getting all of those people together, the right teacher, the right age kids, and having the right materials, the right syllabus. Maybe food can be the same, maybe, but like they mentioned yoga and the rates. All that may be different for a 2 to 3 year old compared to lesser age, like less than 1 year old. They need to have more than one teacher, and they need to have because they may have to change diapers and everything, and the babies may be crying a lot. So that is a process, right? So they have that as a daycare management, they have to think about all that. So that to them is a process. So that is what a business process is all about. Yeah, Taya said you can also have meeting local laws and regulations, right? So they have to make sure they're licensed, that the daycare is licensed and everything, and how they will whether how frequently they're being checked on, whether they have cameras, in the daycare and everything. So Mia, thank you. So Mia said she understood. So hopefully everybody understood business process, because even for me, it took a long time to understand what a business process was. But when you actually sit and think through the problem and think through behind the scenes, what will actually keep going on. Like, for example, if you take a plant nursery, right? So we just go to nursery and buy a plant, but they have a whole business process of when they should start the seeds, when they should where she's potted, what soil they should use, all of that. That's like a process for them, for the business. So that's exactly what business process is. What will take for the business to make that a success, or make that a business goal, and get that successful. Okay. So again, rates based on age and all that, that's again a business process, because they have to sit and think through, okay, how much will it take for them to pay the teacher who has to take care of the child continuously for a long time, and the teacher can't do many things, like that. So that would be the business process. Now, coming down, so now I've kind of an understanding what the business process is, everything. So the questions are now, but this is still in the conceptual, creating tables is still in the conceptual stage. We have not let go of that business person. We're still talking to them. But after getting all of this information, you went back and you thought through the whole thing, and then you're like, okay, so these are the things I'm going to create. You can think through many things, but we have to always be particular about one thing: the grain of the data. Basically, the grain of the data is the lowest level the data has to be boiled down to. Okay, what does that mean? Now, inside a student table itself, we can have the parent information, the teacher information, right? The teacher name and everything. Okay, let me go one layer higher. Teacher-student ratio, for example, right? We are trying to get the teacher-student ratio. We can have a teacher table, and within the teacher table, so if they are just asking the question, hey, what's this teacher-student ratio? You can go and create a table that has one teacher and names of all the students, and then or the count of the students. So this particular teacher, Anju, okay, I'm the teacher. So Anju has 4 students under her, and these are the names of students, right? You can create this one table, a teacher-student ratio table, and create that one table, teacher and the student names, and you'll satisfy that question at that point. But is that scalable? Is it transferable? Can it answer any other questions? Like, can it answer the question, are teachers split, are different students with different ages given different teachers? No, we'll have to go change that table. Okay, so it is not the lowest level of data. Okay, it has to, I hope you understood that. So you have to break the table down further. It is not the atom, right? It has to, that's what the grain of the data is. You need to make sure it is boiled down to the lowest level in order to answer those questions, any question. So because we shouldn't be having to change the tables based on the questions. So tables should be created in such a way that generally, so Leila has asked a question, generally does primary key and unique key refer to the same thing, or is there a difference? Primary key and unique key are different, because primary key should not be actually unique key is also not duplicated, but I've never heard of a unique key. Primary key should be unique actually, and primary key should be not null. I don't think unique key can be not null. Primary key has to be a not null key all the time. Is Marja, Magi, I think, one-to-one with the relationship. I'll come to it to that. So Leila, the primary key and unique key will be different if unique key is not null. Because primary key has to be a not null key. You can't have null primary keys. Okay. Okay, so that is what the grain of data is. Okay, so you need to boil it down to the lowest level. Now, this may be simple, but certain questions may not be simple. But so you need to make sure that you go to the grain of the data. Okay, so so in this table, so what are the different tables I was thinking is that let's have a student table. So student table is going to be a center table here. Student is, because everything on the daycare will be based on the student. So we have student ID, student name, age. I just put in a food allergy there. Then student ID will have foreign keys to teacher ID. So student ID. I'm not going to talk about foreign keys now because that's not something we discussed with the business person. Student ID will still have to be connected to the teacher ID, the parent ID, the assessment. So because from the student ID, we need the teacher information. So from the student ID, we'll know which teacher we're going to, the parent of the student, the assessment, the syllabus. And also, there was a question about rates. So we can also have another table here. I'm going to create another table for rates. Okay. Okay, so we'll have, this is very hard. So we'll have another table for rates also to get the rate information. So that time, this student table will have rate ID, for example. So you'll know which student is paying what rates information. So I'm thinking we'll have a student table, we'll have teacher table, assessments table, the parent table for the parent details, the syllabus, and the materials. Materials, I was thinking more like, how much toys they have, or how much craft work they have, all of that. So these are different tables I was thinking. These are the 6 tables I'm thinking, plus the one more rate table because we added a new question. This is what I'm thinking, and these are actually the grain of the data. So actually we could possibly have the parent information too in the student table. But if there are other questions based on the parent table that we have to answer, we'll not be able to answer if it is in the student table, right? So that's why I've split that into a student and the parent table so that it can go into the grain. Literally the lowest, most possible thing. I don't think we can bring this down into further tables. This is the furthermost table that we can go to. That's what the grain of the data is all about. So this is what I'm thinking. Okay. If you have any questions, please to ask. Leila has a question. Would it be possible to please take a small example from the PPT for primary unique key part? Okay. Okay. Primary unique key. When you say unique key, Leila, what do you actually mean by unique key? like a unique key is something that should not be replicated. Okay, I'll wait on that. But hopefully everybody gets this, what I mean. So this is something that we are going to do in the conceptual table. So we have all of this. Yeah. So basically, with creating these tables, our a conceptual design is done. Okay, going through the tables, we have the conceptual design done. Now, so you talk to them and say, okay, hey, this is what I'm thinking. They may not understand the whole thing, but like a business person, I'm saying the interviewer may understand, because the interviewer may be a data person. The interviewer may understand, but yeah. But with this, we finish this is where we finish the conceptual model, creating the tables. Now let's go to logical modeling. Logical modeling is all you, like as a data engineer, it's all you, where you have to go back and try to figure out all of the relationships, the primary keys, the foreign keys, and all of those details. Everybody can still hear me, right? Mama? Okay, so in the logical model, you're going to discuss how the data model is going to be implemented, right? So in this logical stage, you are going to enhance the concept stage. This is going to be enhancement from the conceptual stage. And here you're going to have all the constraints. The constraints and the relationships, the attributes. Actually, the attributes usually is not added in this phase, but since we're talking through it, we are going to generally does primary key same thing. Yeah, it seems like a primary key is unique key because its primary key has to be, primary key has to be unique and it has to be non-null. That is, it has to be unique key and it has to be a non-null key. So that is what's important for primary key. So that's why maybe it's called a unique key. I think as per my understanding, IDs are usually primary key, but unique key part I'm not yet certain yet. I was referring to some websites online. Okay. But I have actually never in my career so far heard about unique key as a primary key. Like we always talk about primary keys only. A unique key or a composite, if unique key is also called a composite key, that can be different. That is different. So sometimes you can have a composite key where you take two columns and make that a unique key. Because you don't, so sometimes you will be getting data that doesn't have something like an ID or a primary key specifically, and you have to end up creating your own unique key. That will be a composite key where you will be like, you'll take in the, if there's no ID, like name and state of the person, or something too different that can uniquely identify that individual or that row. That can also be called a unique key, but it's usually a composite key.
Yeah, I think, this is a great question, Anju, but maybe like Layla, we can like save this question, I guess, go in further detail on Slack for unique, because it feels like it's a much larger conversation than like what Anju's teaching right now in our session. If that's okay, Layla.
Okay, Layla. We can. If you do have any questions, please contact on Slack and we can discuss further on it.
Okay. Do you want to start from where you were in the beginning again about for logical data model, or I lost track.
No problem. Yeah. So with logical data model is actually an extension of the conceptual data model. Here we're going to talk on the here we're going to talk more on the what is it? Sorry, my son is here. Very sorry. And yeah, here we're going to talk on. We are going to extend that conceptual model we have. We are going to create the relationships between the tables. Actually, here is where you'll actually also create the attributes for the table if you've already not created the attributes on the table. And that's what you're basically going to finish your diagram here. Okay, your entity relationship diagram, you're going to finish it here, so that from here you can go and do the physical model. So basically after that you wouldn't need to After that, you wouldn't need to have to come back to this. So you'll go onto physical. So here we'll discuss that. This is where we are going to do the logical model. I don't want to keep repeating myself, sorry. If you have any questions, please feel to ask me. Now, in the logical model, your business decisions will what attributes should be added in the should be recorded in the database. So you have some attributes, but here you complete it. Okay, so you're like, okay, I need to have this information. This actually also comes into place when sometimes you're taking data from a log. Okay, so you are working on something that is already logging data. For example, your phone data, right? So something like a streaming service or a phone data. So you have the data being logged. So what happens is this stage, you can go, since you're the one who's doing all of it by yourself, you can go and take a look at that logical data, to the log data, and be like, hey, there are these columns. Maybe we could use these columns too. And maybe this can help us further, or help the business further. So those kind of decisions can be made here in this logical model. You're like, what are the other attributes that you can add? So if they've not mentioned it, or if this is something like if you have log data. Now, then your computer science decisions, what relationship schemas should we have, and how should the attributes be distributed among the various relationship schemas? Here we also decide on the column names. Like, you may have already had it, but I had already mentioned in the previous class about fact and dimensional tables. So when you're ending up creating your table, you can have like something like a fact table, which contains all the facts, and then dimensional table that contains more information on that. Since this is only for a database daycare management system, and everything kind of is facts, you don't have to have, but I was also doing a project like crime statistics data. So in that crime data is usually a fact table, because for sure we know these many crimes happen based on statistics and all the data that we have, and then details on where it happened, the city, the location happened, all this kind of a dimensional table that explains where the crime happened. That can be a dimensional table. So that is something you can decide here. And so hence, usually when you have fact and dimensional tables, the table names change to fact underscore, then the table name comes, and dim underscore table names for dimensional tables comes. So those decisions can be made here in a logical data modeling. Okay, so here also we describe the primary key, the foreign key constraints, the null value constraints. So which ones will be null values, which one will be not null values, all that can be decided here. Also here we decide on a fact table, and also here we decide the schema, whether the star schema, the snowflake schema, all of that will be decided here, what kind of schema you want to have. So with that, I will come to my ER diagram. Sorry for this bad diagram, but this is my ER diagram. And I am actually thinking of star schema here, because it's not big enough model for us to have a snowflake schema. Snowflake schema is basically, you have one fact table, then you have dimension tables coming out, or you have fact tables coming out. And from that fact table, you have other dimensional and fact tables coming out, right? So that is kind of like a recursive thing that happens, like a big snowflake thing. In bigger companies with more bigger data, you will have that snowflake schema. This is basically going to be a star schema, because we are going to have a student table as the primary table here. Everything is going to be based on the student table, and all the other tables are going to be connected to the student table. So the student table is going to have the foreign keys here. Foreign keys is basically an identity key to identify the other table that we have in this one table, right? So we have all the foreign keys to other tables here in the student table. So here the IDs will usually be primary key. There should be one primary key, and usually the IDs will be a primary key. If you don't have a primary key, you can make a composite key and make that a primary key, which is you should be uniquely able to identify that student. Okay, should be able to uniquely identify the student. Okay, so I have a few questions here. I'm going to answer that.
I can agree with that, Anju. One question we had from Patricia: do we consider keeping track of the time and how the kids are moving over the years between teachers and groups in the database model?
Wait, do we consider keeping track of time and how the kids are moving between? Yes, that will be yes. We can. Yes, that's a good point. That is that can be tracked in the attribute between the column names. That's a good one to track actually. So you can have other column names like end of school period or end of teacher period, such column names, and we can keep track of that. So adding a column to our schema or to our ER diagram will actually also be part of our business process. So knowing when to keep track of the time, that should also be part of a business process when we're discussing it with the logical, on the conceptual level. And yes, that can also be part of tracking the person, and we also have to discuss it in the conceptual level too and track the person. Okay.
Awesome. Next question. I think this is Maji. I hope I pronounced it correctly. They're asking, I guess, a previous diagram, like, would this be an example of snowflake schema?
This can be an example of a snowflake schema because if you have like here materials, doesn't have to be assigned to a particular student, it can be assigned to a teacher, and then rate is assigned. But this currently is not in a snowflake schema, more towards star schema. But yes, it can be a snowflake schema if you would like. Yes. But snowflake schema is actually unnecessary schema if you don't have too much big data. That's one thing with the snowflake schema.
Awesome. There's another question from ASIN. They're asking, what tool did you use to draw this?
So I have got this online tool, draw.io. Draw.io. If you just Google that, that is what usually I use. Draw.io, because it goes directly to my Google Cloud account. It goes directly to my Google Cloud account, so I'll save directly. My draw.io will directly save there. So
awesome. And I guess the last comment's from Mary. She's saying, you have an assistant for this session.
It's not an assistant, he's just disturbing me here.
Oh, it's okay. You're doing great. And it's like, I agree with like Mary saying like, you're doing a great job, Anju. Really great workshop. Just keep going through. If you need to pause again to give your assistant,
I think his father lured him with the chocolate.
Okay.
So.
All right.
Yeah.
Handing microphone back to you.
So okay. So that's what we have. So the snowflake may be unnecessary for this, but if you have like streaming data or some other data which is large, huge, snowflake will be good. But basically usually for our simple project, you can also have, if you want, in this itself, another. First, actually, I wanted to have snowflake by having this materials irrespective of the student, and making it only with the teacher. So only the teacher is responsible for materials. And also we can have a food table, which only the teacher is responsible for that. I was thinking like that, but then I just want to add food allergy. So that again became like a star schema. And then I also thought, okay, why don't we have materials also part of the student? But you can also have, so how you think through it and how you can help structure the query afterwards. So when you're doing this, you're also thinking of the query in your head, right? So you are also thinking of the fact that, hey, how am I going to get the teacher-student ratio here? So here from this, for one thing is that from the teacher table, how you have a unique ID, so the student ID. Right, a foreign key that's going to identify the student. So you can actually do from the teacher table, you can do a count of the student ID to know how many, for one teacher, how many students are there to satisfy that, right? And then if you want to do age, like under which teacher, what age is there. So from that teacher table, you can have the student ID information, and from the student ID information, you get the age of the student, and based on the count, how many different ages are there. So if you can check from the business process, how many different ages they will be hiring, they will be taking in maybe until only 3 and only until number 4, and then based on that, you can also have a case when. So case when age is equal to 2, make a, count, have a different count, or case when age is equal to this one, have a different count, So from the teacher table, so you're also thinking of the query in your head, and trying to answer those query questions too, right? So, so based on that, you kind of form your tables and you form your student information and everything. Okay, so now the relationship. So for here, the teacher-student relationship. So for one teacher, you'll have many students. For one student, you'll not have many teachers. So those relationships also you'll also be discussing. So you'll know that, hey, for one student, you have many teachers. Then for one student, you'll have many different assessments, right? The assessments on how they're doing at school, if they're given paperwork, how they're doing it, all that. So that'll be like one-to-many relationship. For one student ID, you'll have many assessments. Then for one student, so this student-parent thing was very interesting, because I was thinking, should we have different information for the father of the father, or the father of the baby, or the mother of the baby information? Either we can put on the same table. That is something I was still thinking about. I wasn't very sure. Or this, they can be same gender too. So how we are going to split on that, or we'll just have a primary parent. But is that okay to have a primary parent? So that student and parent it'll be like a one-on-one, because one student, one set of parents, right? Or one parent. We can also have multiple children per parent also we can have. So it can be a one-to-many relationship if they have more than one kid coming in, right? But okay, so that is also a good question, in the sense that we're going to have the same parent ID, right? So if the same parent ID with multiple relationship, so that can be one-to-many relationship too. So I was assuming it just at one point they only have one kid in daycare, but they can also have more than one kid in daycare too, more than one or more than 2 kids. How many more kids they can be that in the table? Yes, is Margie. That is also another thing. So those things also we must. So that is the conundrum that we need to solve as a business problem, right? So that is something we have to make sure that we ask the business person that, hey, will there be one-to-one, one-to-many? But that again, then that may not be something that the business person can solve. That may be something we have to make sure that we are analyzing it, and we are making. That is an edge case. That's a classic example of an edge case that we have to worry about. So that's something you have to think about. Hey, okay, maybe it'll be one-to-one or one-to-many. If it is one-to-many, how is that going to change? Will that change? That shouldn't change, because your student ID is going to be different. Even if there's another student, you're not going to have the same ID. So it's going to be a unique ID, a unique student ID. So it'll still be one. We can still scale it as it's scalable in the future. So when one child is going to daycare, another child is coming in, and they have the same parents, it can still be expanded. It can still be scalable, even though it was a one-to-one relationship. Okay. And then student to syllabus, it's one-to-many. They can have different types of syllabus, right? They can be doing numbers and letters and different types of syllabus. So that would be like one-to-many. And for teacher also, it can be one-to-many. That'll again be a decision from the daycare management system. Will one teacher only be teaching one syllabus or many different syllabus? Yeah. So that is also something you should think about and make sure you're scalable to that, and all that. So this is how we draw the ER diagram. Okay, so let me the question here. So Patricia's asked, do we need to have a student ID in the teacher table, or can we join the information through syllabus? Same with the teacher ID in the student table. Okay, that's actually a very good question, Patricia, because that is something you have to tell me. Okay, you have to tell me that. Do you actually want to do that? Do you think it's a good idea to actually join the student and a teacher table through a syllabus table or through another table? Is it necessary? That is something we have to think about. That's also a business. So that is actually not just a business decision. It's also a performance decision. It's also a query optimization decision. Now, when we can have a teacher, do we need to have a teacher under the teacher table? Do we need to have a student ID? Or can I just not have student ID there and have it somewhere else in the syllabus table, for example, like you say, and have it there. Will that be a query optimizer? No, how much does that query take to run? How much time does a query take to run? Now, if the query takes only 3 seconds right now, or 0.03 seconds right now, when I have like 1 terabyte of data or 2 terabytes of data, will that still be performance efficient? So those kind of questions you need to think about. Is it really necessary adding that row? Is it redundant? That's also something you have to think about, because these are the questions even I was thinking to myself when I was writing. I was actually thinking like how you asked me a question, but I was not thinking for syllabus. But I was thinking like, should I just take out the syllabus information? Should I just take it from the teacher like in the sense from the student table, right? I didn't want to put the syllabus ID there. I wanted to just take it from the teacher. Then I thought, should I do that? Should that be a good performance? But actually, I think by the end of when I finish thinking and when I start writing the article, I may take it out. But that's something you have to think about. And these questions also you can ask interviewer. If you're confused about it, you can ask interviewer. And also in a company, if you're confused about it, you can actually talk to a co-data engineer. You'll have somebody else, right? You can talk to a co-data engineer and ask, hey, I'm thinking like this. I don't want a performance. And then you can think through, hey, the query performance, how is it going to be? Okay, right now, I don't need it. I'm not thinking I need it. But in the future, will I need it? If I need it in the future, will I have to change the table? Do I have to change table dimension for it? Do I have to change the table makeup for it? Those are the questions you can ask yourself and see whether it's scalable, whether it's portable, is it necessary, is it redundant? All those questions, those are questions also you can think about. And right now, since you're doing it on your own, you can have your own justification. But in an interview, you can ask your interviewer, and in a company, you can ask your boss or your PM or a product manager. You can ask them. I'm thinking like this. What do you think? This is a very good question, Patricia. This is a very kind of confusing question. But yes, why do we have it? Why should we have all the IDs everywhere? That's not even necessary. But tomorrow, if you think about the performance, is it necessary? Kind of a thing. Okay. Okay, so Leila has asked, Anju, how can we use composite keys in SQL? Query from this table example in the presentation. Okay. Okay. So in this presentation, how can we get the composite key? Okay, I'll take this parent table, for example. In the parent table, we don't have parent ID, for example. Okay, so we don't have a parent ID. I'm taking out the parent ID. So how are we going to identify the student or identify whose student the parent ID is? Why don't we just take the name of the person and take the student ID of the person? Like student ID of the person. And so if you take the student ID and the name of the person, this person can potentially become a unique identifier, right? Because even if the same parent is Sarah, for example, Sarah is there's a name of a parent for different students, the student ID will be unique, right? So that will still give a unique key. So it'll be like Sarah with student ID 123. So that will give us a unique way to identify this particular table. That will be a composite key. And composite key usually is in this tuple kind of a thing. It's a tuple, created as a tuple. And that will be a composite key. You can have more than 2 columns as a composite key to uniquely identify or to index. Hopefully that answers your question, Leila. And then in my opinion, maybe it should be in different tables unless they are related in some way to the same table. Yes, yes, Leila, it can be, depending, again, since you're creating the database, it is up to you to figure it out. So you can give justification to that. Now you can, that's what I'm saying in the interview, it's good, you think through it, you're open about it, and you talk to the interviewer about it. If the interviewer has no opinion, you give a justification and you can be done. If it's in a company, you work in a company and you hit such a roadblock or such a thought process, you can ask your product manager, your project manager, your colleague, and talk through it and think through that. And these are sometimes decisions that you may have to make with another person, or you can also have your own. But you must always think about scalability, about portability, about performance, about optimization. So if you keep all of this in mind and you have justifications to all of this in mind, you're good. If you think in that way. So as like a data engineer, that's what your primary goal will be, to have an optimized query, to have the good performance. You're not using too much performance. It is scalable. Okay, it is portable, and too many changes the database should not be happening all the time. Okay, so you create a database, you put in the physical model, but hey, they're going and asking for every query, you shouldn't have to change the whole database. That is something you should think about too. So Patricia, okay. Is relation database the best option in this case, since we are not sure about how data tables should be structured, like you mentioned earlier, if teacher ID should be included or not in assessment table. If relation, okay, this is my justification to this, right? So I think it is. I think even though we have all this confusion happened to everything, but I think a NoSQL based database, okay, that's non-relationship database, will not be able to help us much better than a relation database, because we are going to have all this. But if you think about it, if you know relation, like in every table, if you have all of the information or no missing information, will that satisfy? Will we have query performance? Right? If I think through that, I'm thinking, no, hey, relation database base, because this doesn't have too much data in and out. This doesn't have to be a data cloud or a data lake. Right? So I'm thinking through that. And so in my justification is, hey, let's have a relation database. That's, even though we have all these questions, it's fine. Even if I take out the syllabus ID from here, from the student table, and I take the syllabus information only through the teacher table, I'm still thinking it'll still be optimized, even if I have 1 terabyte of data. Okay, because not all the time we may have to keep asking the question, hey, what is this student studying? What is this student studying? Because even if we have that information also, it's a quick scan. One thing for query optimization you should remember is we should not be doing whole table scans. One of the big things for a query optimization is full table scans must be avoided. Because if you have like a whole if you're going through a whole terabyte of data and going through scanning it, that is very bad as a data engineer, for a data engineer. So you should always avoid full table scans. So wherever you can avoid those full table scans, must always be your thought. So for example, if almost every few days, every month or something, or every week, for example, the teacher is going to have to look up what the student is studying, what is the syllabus of the student. That is actually a full table scan unnecessarily every week. But if it is like a quarterly basis, only for grades they're doing it, and so they're not looking it up every time, then you don't have to store the data unnecessarily and just take up space in that storage. You can just do the scan and select your query. It may take some time, but since it's only once a quarter or something, it may be okay. Okay, that is something you can think through, or you can ask the interviewer in this case, or you can ask the business person too. Hey, how long will you be scanning this this one? If then you can think through, hey, this is necessary. So it's basically everything is pros and cons. Whether performance is important or having the data is important. Durability of the data is important. That's what you're weighing. So Nicole has asked, what would be the goal? What would the goal be when creating tables for scalability? The goal for the scalable is you can add data without having too much change in the markup of the table. Like for example, if you're saying, now somebody told me about the rate, right? So I've created the whole thing and then they spoke about rate. Now, is it easy for me to update this schema to add rate table? I'm thinking yes, because I just have to create a rate column, a rate entity, rate entity, and add the rate entity to the student table. So it's not that big deal. So I just have to create a table, create an ID and everything for the table, get all of the rate information, right? And then add a foreign key in the student table, which shouldn't take too much. And the rate is into the schema. So that's what I think about the rate. Now, for example, if the teacher, the student and the teacher and the parent information are all in one table, I may have had to go and put the rate information into that table. Now that is a change of the whole table. That's not good. That's not scalable. That's not how we can. That's why the grain of the data is important. Okay.
Anju, I see we have 2 more questions. I'm just wondering how much more of the content you need to.
No, I think this is the last slide. So
that's like, okay, yeah. So up to you for your flow.
That's the last slide. So that's what, Nicole. So you have to think about scalability is how much change you need to make to an already created table to add your to add something. Okay. Like, do we want to normalize the data? So normalization actually will also come in this part, but it'll actually come in the physical model when you're creating the table, but also come in this part. So yeah, like, do we want to normalize the data? Yes, we need to make sure we have to normalize it. So normalization is nothing but getting the grain of the data. It must be, the atomicity must be there, right? You know, the asset transactions, the atomicity and the durability, all that. So yes, that is what we talk about, Nicole, like that. Okay. So Samina said, how do we know if table structure is scalable, or if the way a SQL query is done is scalable? SQL query is, we don't have to worry about SQL query being scalable, because SQL query is, you can do the, I don't know if you mean just a SQL query, but it's usually you can. But when you say scalability is how, when you add a new set of data, how much change you have to make to the original schema is what you have to worry about scalability. Okay, so like, for example, like I said, the rates column. So you're adding the rates column. Are you how many columns are having, how many tables are having to change? How many columns are you going to have to add to a particular table? So if you are you going to have to add columns? So the rate, we can actually create, since you can create a rate table on its own and just change the student table to add the connection, it's not much. So it's actually considered scalable. Now, if you can't do that, you have to change an existing table, then it's not scalable. Hope that answered your question, Samina. That's what scalable means. Structure is scalable. How do you know? So how much of change you have to make? So to answer your question directly, how much of a change you have to make to your original schema is what scalability is considered as. If you don't have to make too much change, it's scalable. If you have to make too many changes, it's not scalable. So Mary asked, are full table scans different from frequent updates and inputs? Yes, I think she has answered the question. It's like full scan is scanning row by row, every row. So that, yes, full scans and actually frequent and updates inserts are different. Full scans is a scanning. So when you're like joining 2 tables, right? For every student, you're going through every teacher. And so there are like 10,000 students or 100,000 students. You're the 100,000 students of one table and the 100,000 teachers of another table are being scanned. So it's like 100,000 into 100,000. So 100,000 of, it'll be an exponential number, right? That is not something we should be able to do. Like every column in one row, scanning every column in another row, that many times should not happen. Every row in one column, scanning every row in another column should not happen. That is what full scan is on.
Your assistant is very enthusiastic. I guess we can wrap up this session then.
Yeah, there are more questions. I'm sorry. I'm very, very sorry. He's going on coming inside because I think his father is very busy. He finished his chocolate and now he's back.
Okay, it's a good time to wrap up. It's like a really great informative session, lots of knowledge. You need to answer like a lot of the questions that we had. And yeah, if anyone else has follow-up questions, definitely post in the Slack, the data science study group, and Anju can answer them. Yeah, thank you so much, Andrew. This was like fantastic.
Yeah, if you have any
I was
questions,
impressed by
post.
I was
Yeah.
impressed by like the content you prepare and just like the way you like share and distill the knowledge, because like it's a lot if you're a beginner or just like refreshing your skills. So we appreciate it so much.
Thank you. Yeah.
Thank you.
So if you have any questions, please. So I hopefully this you were able to get everything from the session, because this is actually very important, data modeling. So if you have any questions, please feel free to message me on Slack, or you can also message Eliza, and she can direct the question to me, and also in the group. So I think Nicole has asked which was
The Slack channel, I think data-science-st dy-grp. This will wrap up. So I saw there's a lot of thank yous, Anju, but yeah, so good morning, good afternoon, good evening, wherever you are, and I hope everyone has a great rest of April. All right, bye.
Thank you.